As I have indicated previously in this space, I am not a climate scientist. I began studying climate change when I was in graduate school in the early 1980s, but I have never claimed to be a climate scientist. Therefore, when a headline included the Walker circulation, I was stumped. I did what most of us do several times each day. I used an online search engine to investigate the Walker circulation, which I learned is a climate change phenomenon. My search for the Walker circulation led directly to an article in phys.org, which led to a peer-reviewed paper in their renowned Geophysical Research Letters. I'll start with the former article. The article at phys.org was published February 25, 2025, entitled Competing Effects of Global Warming and Sea Surface Temperature Explain Recent Strengthening of the Walker Circulation. Here's the opening paragraph. Quote, the Walker circulation, an atmospheric circulation pattern in the tropics, has accelerated in recent years, puzzling climate scientists who had anticipated the opposite. Researchers from the Max Planck Institute for Meteorology and the University of Tokyo have found out why by revealing the competing effects between global warming and the near surface and the sea surface temperature pattern effect. End quote. This paragraph does not explain the Walker circulation. Neither does the next one, although it does hint at the location of the Walker circulation. Quote, some of the climate system's responses to global warming are rather surprising. Contrary to scientists' expectations, the Pacific Walker circulation, a large-scale circulation in the tropical atmosphere, has strengthened in recent decades. End quote. Thank you for your patience. The next two paragraphs provide an explanation of the Walker circulation. Quote, why this is the case and how the Walker circulation might develop in the future are urgent questions. After all, it impacts weather patterns far beyond the tropics. This can be witnessed during La Niña and El Niño conditions, phenomena that are known to cause extreme weather in various regions of the world, with the former being linked to a strengthening and the latter to a weakening of the Walker circulation. The Walker circulation forms over the tropical Pacific, where the western Pacific is typically warm with low sea level pressure, and the eastern Pacific is cooler with high pressure. Warm, moist air ascends over the West Pacific, while cooler, dry air descends over the eastern Pacific. Near-surface equatorial trade winds, blowing east to west, complete the circulation loop. End quote. So finally, there we have it. The Walker circulation is a large-scale atmospheric circulation pattern that moves air from east to west across the tropical Pacific Ocean. It is a fundamental part of the El Niño Southern Oscillation climate system. I have discussed the El Niño Southern Oscillation, the ENSO, and its importance in previous videos. An even clearer explanation of the Walker circulation is provided further into the article at phys.org. Quote, the Walker circulation, defined as the difference in sea level pressure between the West and East Pacific, and the subgrid scale convective mass flux, a direct measure of convection strength. The convective mass flux is expected to decrease with increasing temperatures because the atmosphere becomes more stable due to amplified warming in the upper troposphere under global warming. This reasoning is in agreement with observations. End quote. Although I'm not a fan of the writing style, this explanation is relatively clear. The Walker circulation describes the difference in sea level pressure between the western and eastern areas of the tropical Pacific Ocean. In so doing, the Walker circulation facilitates the movement of air from east to west across the tropical portion of the Pacific Ocean. Here's the important statement. Quote, the convective mass flux is expected to decrease with increasing temperatures because the atmosphere becomes more stable due to amplified warming in the upper troposphere under global warming. End quote. According to the article at phys.org, a weakening of the convective mass flux has been commonly used to argue that the Walker circulation will also slow down. However, the observations reported in the peer-reviewed paper told a different story. The reason? The Walker circulation is not as tightly coupled to the convective mass flux as previously assumed. It does weaken due to global warming, but unlike the convective mass flux, several factors can counterbalance this tendency. Most notably, the sea surface temperature pattern is demonstrated in the peer-reviewed paper. The peer-reviewed paper was created by 3 scholars and published on February 28, 2025, titled Common and Distinct Drivers of Convective Mass Flux and Walker Circulation Changes. The open access paper appeared in Geophysical Research Letters, the leading peer-reviewed outlet of the American Geophysical Union. After the abstract, the peer-reviewed paper provides 3 key points, followed by a plain language summary. The 3 key points are: 1. Convective mass flux weakens in proportion to the global warming amplitude, largely unaffected by sea surface temperature pattern changes. 2. Walker circulation weakening due to global warming can be overcompensated by a sufficiently large increase in zonal sea surface temperature gradient. And 3. The weakening of convective mass flux alone is insufficient for explaining the Walker circulation response to global warming. The plain language summary is clearer than anything I've described so far in this video. Quote, global warming is known to weaken both the convective mass flux and the Walker circulation. Yet, in the past decades, the convective mass flux has been weakening, while the Pacific Walker circulation has actually been strengthening. To investigate this discrepancy, we conducted a series of experiments with varying sea surface temperatures. Our results revealed that the convective mass flux weakens with global warming, largely unaffected by sea surface temperature pattern changes. On the other hand, the Walker circulation's response is greatly influenced by sea surface temperature patterns. It can strengthen if the zonal sea surface temperature contrast across the tropical Pacific is sufficiently large despite global warming. This suggests that accurately projecting the Walker circulation requires a better understanding of sea surface temperature pattern changes. Never mind that the researchers are, of course, calling for more research. The critical issue demonstrated by this peer-reviewed research is that although the Walker circulation generally weakens with global warming, this general pattern can be disrupted by changes in the sea surface temperature. As a result, the Walker circulation might continue to strengthen if sea surface temperatures continue to rise. Sea surface temperatures will continue to rise as long as abrupt, irreversible climate change continues. I see no way out of this strong, ongoing pattern.